Hello friends, now we see the simulation of resistive load inverter. For this, first we go to the NI multisim 14.1. First we design the circuit. For that we go to the place, then component. Here we select the transistors, virtual transistors. Then we take the MOS N transistor. We take the 3 MOS N transistor. Then we have to go to the basics and take resistor. Here also we need 3 resistors for load. After that we go to the sources. Here is the power source. We need a DC source for a VIN and another DC source for VDS, and also we take the ground. Then we rotate the resistors to connect appropriately. Here we design the circuits. First change the resistor along with CMOS, and then it can connected to VDS. It is the VIN used to the VGS of all transistor. Now the circuit is ready. Next we will put the values of parameters. Here is the input voltage. It is a 0 volt. We change the label. It is VIN. Next this is RL1 and value is 20 kilo ohm. Here 120 kilo ohm, and label is load resistor 2. Here load resistor 3 and value is 220 kilo ohm. Okay. Next we put the values of transistor. Here by the problem statement our W by L is 2, so here length is 100 micro and W is 200 micro. Next we go to the edit model. Here the threshold voltage given by the problem statement is 0.8 volt and our transconductance is 20 micro. Next here we check the W by L. This is used for the default. First we unmark this and then change the value of W. It is 2. then go to the change component. This process same to the all three transistors. Then also change component. Okay, and for first transistor, then go next edit model, then threshold voltage 0.8, kp is 20 micro, w by l is 2, so width is 2. The next change component. Okay, then we set the VDD given by the problem statement. It is 5 volt. We change the label VDD. Okay, VDDS. It is not only VDD, it is VDDS. Then we go to the simulate, place, then go to the probe, select voltage. There is the shortcut for the voltage is here and here. This is the voltage probes which shows the voltage values. Then go to the simulate, then analysis and simulation. Next select the DC sweep. Here change the value which is 5 volt and which is increment by 0.1 volt. Then see the output. Here is the all output is added of probe 1 voltage, probe 2 and probe 3. So save this and here run the simulation, and these are the outputs. Here is the DC transfer characteristics. Then go to the show cursor. Here is the window for the see the output voltages. This is for the 20 kilo ohm, this is for the 120 kilo ohm, and this is for the 220 kilo ohm. Here this is denoted by the red line, here is the green line, and here is the blue line. So first we observe the calculations by this value. Here we go to check the values. Here first we select show cursor, then there is the for RL 20 kilo ohm VOH is 5 volt, so we move the cursor to 5 volt. Here you see 5 volt for 5 volt the low output voltage is 1.30, which will match from the calculated value. Next we see the low input voltage. For this we move the circuit we move the cursor to 2.05. For 2.05 the V out of VIL is 4.37 for calculated value, and here it is 4.36, so it is matched up. And third is VIH. For this we move the cursor 3.63. as you see the calculations for 3.63, our calculated value is 2.04, and here also the both values are same for VIH. Next we see for the load resistors 120 kilo ohm. For load resistor when 5 volt, our calculated value is 0.23, and here it is 242.99 in milli. When it converted in micro, it is 0.24. It is actually same. For a VIL, we move the cursor to the 1. When VIL is 1, our calculated V out of VIL is 4.89, and here we see there is the observed value of V out VIL is 4.89. Next we see the VIH. For this we move the cursor to 2.31. Here 2.31, the V out of VIH is 0.78 and our calculated value is 0.77. So it is also actually same. Next we see for the 220 kilo ohm. So click here and check for the first 5 volt VOH. Here 5 volt, and our calculated output is 0.54, and here we see, sorry, here calculated value of VOL is 0.15, and here is the 0.13. So it will not actual, but it will be same. And for VIL we move the cursor to 0.91. Here our calculated value of V out of VIL is 4.94, and here is 4.93. So it's same. Next for VIH we move the cursor to 1.9. And for 1.91, here our output is 0.61, and calculated V out of VIH is 0.60. So as we see, our all observed values are matched with calculated values. Thank you.